So now we're talking about reflections. First thing we need to, everyone kind of has a pretty good idea of what a reflection is. You look at yourself in the mirror, that is your reflection. It's the exact same thing on the other side of the mirror. So, it's not really the other side, but it looks that way. So, perpendicular lines, first of all, they intersect at a right angle. That is very important because down here the very bottom line says, when you are reflecting, you need to reflect with a perpendicular line because that is your line of reference. Gives you your reference for the reflection. So we'll come back, we'll talk about that in a minute. So perpendicular means it intersects at a right angle. If it's a perpendicular bisector, it also cuts it in half. So it's perpendicular with a right angle, but it also cuts it in half, two congruent pieces, two equal pieces. Which means it goes through the midpoint. All those constructions that we've been doing to get a bisector, those have actually been perpendicular bisectors. They always go perpendicular with the method of construction we were using. So a reflection just maps it over whatever line we're reflecting over. So it needs to be perpendicular, so you have the accurate reference for it. And it's also going to be the same distance on both sides. So that's where the midpoint or perpendicular bisector came in, because it's going to be the same distance on each side of the line that we're reflecting over. So when you are going to do a reflection, you need the perpendicular line, which we will talk about how to get, and you need to measure out the distance. So yes, you could do distance formula. You can just count how far away it is, left and right or up and down, and it would be the exact same. So when you are drawing the image after a reflection, you draw the perpendicular segment that goes through one of those points. So if we're going to reflect A, you draw the perpendicular that goes through A. And then you measure out how far that is. So you'd have to go 2 units to the left and 2 units down. You'd make a similar triangle on the other side. So if you go 2 and 2, you have to go 2 and 2. So that will give you the same distance. Or you could just kind of count it out diagonally. There's 2 diagonal boxes it goes through, 2 boxes it goes through diagonally. They are congruent. So A and A prime. Now to repeat those steps with B, if it's perpendicular, since this one is going down, perpendicular is going to be going up. And since it's just down 1 over 1, that's what we're looking at mostly. We just have to reflect perpendicularly along that line. It is perpendicular because this one's going up instead of down. The other one goes down 1 over 1. This line goes up 1 over 1. And then we need to count how far out B is. So right now B is only 1 diagonal unit away. So we need to go on the other side 1 diagonal unit away. Or you can make it into triangles and see that they're the same triangle. So this is going to be the image of B, which we call B prime. We're going to do the exact same thing for C. It has to be perpendicular, so we'll be going that way. Instead of down 1 over 1, it goes up 1 over 1. And then C, that is, you could make the triangle if you want. You can also just count it's 1, 2, and a half diagonal units. 1, 2, and a half. So we go, there's our half, and then 1, 2. That is C prime. So it will look very similar. It's just the mirror image. So if I get rid of some of this extra stuff, you'll see just the mirror image. If line L was the mirror, it's on the same thing. If you were to fold it on L, it would match up. So for a little bit better description of perpendicular, you hopefully remember this from a previous math class. Perpendicular lines will have opposite reciprocal slopes. So if you count out the slope, this one goes up 1 and over 2. The first line goes up 1 and over 2. As a slope, we would say rise over run, so that would be positive 1 over positive 2. Be 1/2, that's our slope, 1/2. Now the perpendicular slope is the opposite reciprocal. So if this is 1 over 2, you have to flip that to be 2 over 1, or just 2. And opposite means we change the sign. So if this one was positive, the opposite will be negative. Reciprocal means flip it. Opposite means change the sign. So if this original line goes up 1 over 2, the perpendicular line is going to go down 2 over 1. So let's take point A here. We want to go from A, we need to go perpendicular. So it's going to go down 2 over 1. Down 2 over 1, down 2 over 1. That will be our perpendicular. You can see it looks perpendicular. And we know it's perpendicular because of the slopes. We figured out the slopes. So you can count this if you want. It needs to go down 2 and over 1. So it's going to go down 2 and over 1. That's where A is going to end up, the same distance away. Down 2 over 1 to get to the line, down 2 over 1 more to get to the image, A prime. Do the same thing for B. Slope is -2, so from B, we need to go down 2 over 1, down 2 over 1. There's our perpendicular line. For our accurate reference there. And then we had to go, to get to the line, we had to go down 2 over 1. We had to do that twice. We have to do it twice. That's how far away B prime will be. Down 2 over 1, down 2 over 1. We do that twice to get to B prime. If you look, you could even fold your paper if you want. You will see that they match up. It's the same distance away if you fold it right across line L. It matches up perfectly. And then point C right here, that's on the line. So if we're on the line, you reflect over the line, you're still on the line. So that's where C prime is going to be at the same place. So 0 distance away, we're going to stay 0 distance away. So here's all of our points. You connect them, and there's the reflection. Again, if you were to fold the paper in half, everything would match up. A would match up with A prime. B would match up with B prime. Everything would match up if you fold it on line L.